Okay, so the last question that we're going to do on the 2019 free response is number 5, which states, a company that manufactures smartphones developed a new battery that has a longer lifespan than that of a traditional battery. From the date of purchase of a smartphone, the distribution of the lifespan of the new battery is approximately normal. That's important. With mean 30 months and standard deviation 8 months. So on average, it lasts for 30 months, the battery, but standard deviation of about 8 months. For the price of $50, the company offers a 2-year warranty on the new battery for customers who purchase the phone. The warranty guarantees that the smartphone will be replaced at no cost to the customer if the battery no longer works in the first 2 years, within 24 months, which is the first 2 years from the date of purchase. So, honestly, I was surprised last year when this question came out. I really thought it was a pretty fair question. We'll start off with A. In how many months from the date of purchase is it expected that 25% of the batteries will no longer work, and justify your answer? So it's saying what is the number of months that indicates the 25th percentile when 25% of the batteries stop working. So for A, a couple of things. So it's a normal distribution with a mean of 30 and a standard deviation of 8 months. How did I find it? I did inverse norm, area 0.25, mean 30, standard deviation 8. Now I put a star because remember calculator talk, better to draw the picture. If the mean is 30 and you're finding the 25th percentile, that number comes out to, when I do inverse norm, 24.6. And I wrote a little sentence. After 24.6 months, we would expect 25% of the phone batteries to no longer work. Part B. Suppose a customer who purchases the warranty is selected at random. What is the likelihood that the customer selected will require the replacement within 24 months? Well, if you're trying to find what's the likelihood of the battery breaking in 24 months or less, that's just a nice, simple, normal CDF. So the warranty equals 2 years, which is 24 months. Probability of a battery stops working in the first 24 months, I got 0.2266, right? Normal CDF, lower bound negative 99999, upper bound 24, mean 30, standard deviation 8. Draw the picture, state the area of it. The picture will suffice as sufficient work. Now, you don't have to state that the distribution is normal again because we did that in A. Keep that in mind. I think I forgot to mention that you need to have a statement somewhere that says it's a normal distribution. You just can't go ahead and do normal calculations without stating it's a normal distribution. That is very important. Keep that in mind for future problems. Now, part C. The company has a gain of $50 for each customer who purchases the warranty and does not require a replacement. Obviously, because if they pay $50 and they don't get a replacement, they gain $50. But if they need to replace it, then guess what? It's going to cost them $150 to replace the battery. So it says, what is the expected value of the gain for the company for each warranty purchased? So in the long run, what's happening here? Well, they lose $150. We figured that out 22.66% of the time. That means they gain $50, 0.7734 or 77.34% of the time. So they lose $150, a lot less, but does this outweigh it? Is this a positive expected value? And that's that key word here, expected value. We haven't done one of these in a while, but expected value, let's take a look. Well, the way to do it in the calculator is L1, put your values, and L2, put your probabilities. You're going to then run a 1var stat, list in L1 of values, and then the frequency list in L2, that's your probabilities, how often L1 happens, and you look at the mean, X bar, 4.68. So what does that mean in the context of this problem? After many, many warranties are bought, they expect to profit $4.68 per warranty bought. So yeah, sometimes they'll pay $150, sometimes they won't have to pay $150, they'll gain $50, but in the long run, they gain, for every person who buys a warranty, they'll make about $4.68.